So today we start that is battery charger using regulator. This is another circuit that we can observe from the industrial control circuits. In previous lecture we can observe that is the simple battery charger using ACR, but the circuit is having the one drawback, and the drawback is the voltage across the battery is not sensed. So here we can replace or here we can modify the circuit, and we can overcome the drawback of that battery charging using SCR. So alternately, the some here we will add the some extra values here. So the circuit name is that is called as the battery charging using regulator, and by using this circuit we can change the voltage across the battery. So how we can change the voltage across the battery? So here you can observe that there is one rectifier that is called as a R3, and another capacitor here we will also call as this is a C3. So the combination of these R3 and C3, it is called as that is the sensing elements, or they will sense the voltage across the battery here. So here we can observe how the circuit is work. So particularly again from the first circuit that we can observe, basically here you can observe that the AC supply, again the 230 volt AC supply that we can use here, and we can provide the supply across to the transformer. This one is that is the simple step down transformer we can use here, and the circuit here this transformer will be maintain the voltage across the winding. Okay, primary to secondary winding the voltage is coming. So this step down transformer will be generate the good quality of the voltage across the secondary winding. Then the secondary winding will be provide the voltage across to this rectifier voltage. This is the rectifier circuit that we can observe. The combination of the two diode, that is called as the diode D1 and the D2, they will act as the rectifier. So by using these two diodes we can convert this AC signal into the DC. Now this DC supply is coming across to the ACR. So here I will write down the rectifier voltage AC to DC signal, and this DC signal is coming across to this ACR. Now here you can observe that the battery is connecting across in series with this ACR. So the point is that whenever the ACR is turned on, then when the SCR is turned on, the battery voltage or the battery will be start to charging, and when the battery will start to charging, then this circuit, then the combination of this R3, C3 and Z1. Z1 stands for Zener diode. So the combination of these circuits will act as to change the voltage across this battery. So let's we start how the ACR is turned on and how the battery voltage is regulated or start to charging. So basically when the rectifier voltage is coming across to this ACR, okay, the first thing is that when the voltage across to the battery, now it means that the actual level or actual voltage across the battery is that is the 12 volt. So whenever the voltage is coming from that is this rectifier circuit, okay, when the signal is converted into AC to DC, and this DC signal is coming across, when the signal is low, the voltage that will be coming across to this SCR is low. Suppose the voltage coming across to this SCR is low, then the SCR is not turned on. Okay, so when the SCR is not turned on, then the battery is not start to charging. So this R3 and the C3 circuits means combination of this rectifier and the capacitor is not sense any voltage across the battery. So the Zener diode is in reverse. Zener diode is not turned on, it's not maintained or it's not regulated the voltage. Okay, and due to that the SCR2 is not also turned on. So basically how the circuit is work. Okay, when the voltage is coming across to this circuit, this rectifier voltage when increases slowly, then after some times when the good quality of the voltage or the high voltage is coming across to this SCR. आता here we can observe how this SCR is on. This rectifier voltage will be transferred to this resistor R1 here. The voltage is coming from this point, and this rectifier voltage is coming across to this R1, then to the diode D1. Okay, and then it provides to the gate of the SCR, because already we are knowing that the gate is the control terminal of the SCR, and this gate will be decided when the SCR is on and off. So particularly when the more and more voltage is coming, and when a good quality of the voltage is coming across to the diode D1, then the diode D1 is comes across to the forward bias condition, or it will becomes into the forward bias condition. It means it is turned on. When the diode D1 is on, then it will be provides the supply voltage across to the gate, and then gate will decided when the SCR is on. It means when the maximum voltage is coming across to this gate, then and then the SCR is on. The point at which SCR is on, then the battery will be start to charge. Whenever the battery start to charging, then here we can observe that the resistor R3 and the C3 will start to mm, charge, or it will be start to change the voltage across the battery. So here you can observe there is the one voltage that we can observe here, that that is VR stands for, that is the rectifier voltage. Okay, so here we will observe when the battery is start to charging, then the R3 and the C3 will also change the voltage across the battery. Then the Zener diodes is turned on. Zener diode is turned on, and it will be regulate the voltage properly. It will be maintain the constant voltage. Okay, so when the battery is charge continuously, and when the battery is reaches to the 12 voltage, from this R3 and the C3 and combination of this diode, Z1 Zener diode, we can change the voltage across the battery. So when the battery starts to charging, that says from 1 volt, 2 volt up to 12 volt, after 12 volt, the Zener diode is regulate that voltage, and when the battery is reaches to the 12 volt, then the Zener diode will be provide, or it will be change this voltage, and it will be provides the one type of the gate pulse across to the SCR. When this 12 voltage battery is fully charged, then the Zener diode will be cut down, and it will be provides the supply across to the SCR2. And when the SCR2 is on, the point at which SCR2 is on, that points the diode is goes into the reverse bias condition. That means this diode is goes into the reverse bias condition, and the voltage that will be come that the voltage that gets to this SCR is break, because the reverse voltage is coming across to the SCR, and the SCR is turn off easily. Means the supply across to the SCR is off. Where the supply is off, automatically the batteries is stopped to charging. So this R3C3, or combination of these three components, we can change the voltage across the battery, and when we are observe the battery voltage is reaches to the 12 volt, automatically this SCR is off, and the battery charging is stopped. So how the battery charging is stopped? This Zener diode will be providing the gate pulse across to the SCR2, and here the SCR2 is on. So basically we will also say that because of turn on to the SCR2, the SCR1 is off, because the diode is goes into the reverse bias condition, and it will be provides the reverse voltage. The voltage across this SCR is comes across to this diode, and the reverse voltage is get to the SCR1, and SCR1 is off. And when the SCR1 is off, at, uh, automatically the battery's voltage is not sensed, or the battery is not charging, it will be stopped. So in this manner we can regulate the voltage across the battery. We can regulate the voltage, it means we can change the voltage across the battery, and due to this working principle, they are given the circuit name is, that is battery charger using a regulator. So these three R3, C3 and the Z1. They will change the voltage across the battery continuously, and because of these three components we can change the voltage properly, and we can turn off also SCR1. And when the SCR1 is turned off, naturally battery stops to charging because this battery is connecting in series with this SCR. Okay.